Good morning to all of you. Welcome you guys. Welcome you all. How are you doing, everybody? Right, we are live. First of all, do check करके बोलिए now. Is the audio videos clear to everybody? Audio video is clear to everybody? Yes. Now the Unacademy subscription that is just 8,999 only. Now the Unacademy subscription that is just 8,999 only. इसके साथ एक्सटेंशन भी आपको मिलेगा. The extension भी आपको मिलेगा. Now that is flat 60% of discount, and you can use the offer is valid up to 15th of June. That is today is the last day to avail this opportunity. Utilize the code of Reddy to avail this great opportunity and have a great learning experience from the top educators team. So you can have a look at now. These are the top educators of Unacademy. You can have a look at now. From 12th onwards, we started a नया batch शुरू किया and digital and then EMFT started. Start your serious preparation with the Unacademy to achieve your dream goals. Right, this is for 2028 का batch है. So 12th June onwards, this batch has been started. You can have a look at now. Now this Unacademy 2026 का rankers you can find. ESC 2025 rankers. ESC 2025 का rankers you can have a look at. Now we do offer the two subscription. One is plus, the other one is iconic. And plus में क्या चीज मिलेगा आपको? So here top educators classes मिलेगा, live doubts, evaluated test series, and structured courses, live test, unlimited access. Iconic में और क्या मिलेगा इसके साथ? So here personal coach भी मिलेगा, physical notes भी आपको मिलेगा. So you can start a serious preparation with Unacademy to achieve your dream goals. We are there to provide you the best knowledge. Let's crack it. Right. So last class we have discussed some problems. Let's continue the remaining problems in these sessions. Yeah, how many problems we have completed in the AC circuits we started now? We are doing AC circuits problems we are doing, right? 25 completed. Next one, 26. So an AC source is connected in the given series LCR circuit. The RMS potential difference across the capacitor is voltage is given. So this means they are asking to find this RMS value. RMS, that is voltage across the capacitor, they are asking to find. We need to find the VC now. Right. First of all, you can see now omega value given as 100. Omega value given as how much now here? 100. Now let's tell me now inductive reactance is how much now? XL is equal to, that is omega L. So how much will come here? This is 100. 100. And whatever Hc you tell me now here, capacitive reactance is 1 by omega C, and which will be equal to 1 by, so 220 into omega value 100 into 10 power minus 6. Now, how much will the Xc value tell me now? So 1, 2, 3 zeros will get cancelled here also. Now, so then it will come to be what tell me now 500. We got Xc value 500 we got now. Now you can tell me now voltage across the capacitor, which will be equal to this is minus jXc, capacitance minus jXc by, so resistance is 300 plus J into XL minus Xc na. How much this value? XL value 100 minus 500 into how much is peak value? This is 50 root 2. And we need to simplify, get the value of RMS voltage. This is minus jXc value. How much you tell me now? 500. 500 by what tell me now? This is 300 minus J 500. J 400. J 400 into how much now? That is 50 root 2. Yes, so how much this value, this magnitude of VC, which will be a 50 root 2 will come now? And they ask him to find what you tell me now here. What they ask him to find the RMS value. This is the peak value. So that means what will be the RMS value? Tell me now. RMS value, which is equal to VC by root 2. So which will be equal to what I will get now here? 50. Right. Got it all of you? Next one. A series LCR circuit is subjected to a AC signal of 200 volts 50 Hz frequency. The voltage across inductor is 31.4. The current in the circuit is they given this as series LCR circuit. And the circuit which is given like this. How much is value? 200 volts and 50 Hz frequency. And inductance is given as a 10 milli. They didn't given about the resistor and capacitors not mentioned. They didn't given about the resistor and capacitance values. And the voltage is given. How much is voltage they are saying here? This is 31.4 volts. 31.4 volts. We know voltage, current we can get now. So this means obviously this current, which is equal to I, and which will be equal to what I can say now, 31.4 by, we can say now this is omega L, reactance of inductor. So how much this value tell me now? 31.4 by omega. So 50 100 pi into inductance is how much? Inductance is 10 milli. So 10 into 10 power minus 3. So this is pi means we can cancel with what tell me now? 10 and this pi will get cancelled. So this I value will come to be 10 amperes. The I will come to be a 10 amperes. Right. Next one. In AC circuit, the instantaneous current is 0. Okay. When the instantaneous voltage is maximum. Okay. In this case, the source may be connected to pure inductor, pure capacitor, resistor, capacitor. Choose the correct answer for the following. Uh, Current is 0. So this is the instantaneous current is 0. That means I of t 0. But voltage, instantaneous voltage, which is maximum. Then what will be the option now here? So now that means there is a phase difference between voltage and current is how much? Phase difference between the voltage and current, which will be equal to pi by 2. A plus pi by 2 or minus pi by 2. Now you see this thing for inductor. Inductor is a lagging element. Phase difference between the voltage and current is pi by 2 only. Capacitor is also phase difference is pi by 2. But resistor phase difference is 0. So this cannot be, we cannot achieve these conditions. And combination of inductor capacitor. In this case also phase difference between voltage and current is pi by 2. So what's the option? Tell me now. We can connect to A, B, D. In these cases, we can achieve it now. So we cannot achieve full resistor. The resistor case phase difference between voltage and current is how much? 0. Phase difference is 0. Okay. Next one. Now, so choose the correct answer from the options given below. Yes. So purely capacitive circuit. Capacitor is a leading element now. So here current leads the voltage. So in this case, first one. Now inductor is a lagging element. So this is fourth one. Current lags. LCR circuit resonance. That means so voltage and current are in phase. That is 2. LCR series circuit, there will be some phase angle. So this is 3. So 1, 4, 1, 4, 2, 3. So option D, the phasor diagram problem. And what is the capacitive element? Capacitor is a leading element. Capacitor is a leading element. So in case of capacitor, what happens now here? So here for capacitor, current leads the voltage by 90 degrees. Current leads the voltage. Current leads the voltage by 90 degrees. Okay, next one here. Inductor is a lagging element. Inductor is a lagging element. In case of for inductor, current lags the voltage. Current lags the voltage by 90 degrees. Next, so here at a resonance, what happened? At a resonance, impedance is purely resistive now. Impedance is purely resistive. Purely resistive. So, phase difference between voltage and current is zero. Phase difference between voltage and current is zero. Okay. Next one. In a series LCR circuit, the capacitance is changed from C to 4C to keep the resonance frequency unchanged. The inductance is, yes, what is the resonant frequency? Omega naught is equal to 1 by square root of LC. Now the capacitance will becomes double, then inductance has to become 4 by 4 has to become. So that means now here C2 becoming what? Tell me now, 4 times of C now. That means L2 will becomes what? Tell me now here, L by 4. L2 become is L by 4. The new inductance should be, keep the resonance frequency, and the new inductance should be, how much this value? New inductance is, okay, they are asking reduced, they are asking. How much is reduced now here? New inductance is this much. How much reduced now here? So that means initial minus final. L1 minus L2. Initially we have L. Finally we have L by 4. So that means what we can say now here? 3L by 4. Next one. An AC voltage is applied to a series LCR circuit which drives a current I is given. The average power dissipated is, and what is this power now? Average power P, reactive power now, which is given as VRMS, IRMS into cos phi. So this is VRMS is what? Tell me now, 20 by root 2. IRMS is what you tell me now, 10 by root 2 into cos phi. Phase difference between these two, how much now? 60. So this value 20, 200 by 2, cos 60 means 1 by 2. So tell me now how much will come here? This is 100 and this is 50. So that means average power which is equal to 50 watts. A series LR circuit connected with an AC source is given has a power factor of 1 by root 2. Okay. If the source of EMF is changed to this much, The new power factor is power factor is given. So yes, power factor does not depends upon the source. Now power factor depends upon the circuit connections. Yes, 32 I think same only, isn't it? Oh, but omega value changed now. Okay, in the omega value change. Yeah, this omega value 1000, the omega value 2000. Okay. Now, if I call the impedance LR circuit, which is given as what I'll know R plus j omega L, basically j omega L. And what is the power factor? You tell me now here, which is given as what? Tell me now R by mod Z. Power factor, which is given as what? Tell me now R by mod Z. So that is R by mod Z value how much? That is square root of R square plus that is omega L whole square. This value they given as what you tell me now 1 by root 2 they given. Okay. Now they change the omega value 2000 they made. This is omega, we can say omega 1. Now we need to find the new power factor. That is PF2, which will be given as R is remain same only. That is square root of what you tell me now, this is R square plus omega 2L whole square. Now we can take a ratio now here. This is PF1 by PF2, power factor 1 by power factor 2. Yes, so this value will come to be what? Tell me now, this is R by that is square root of, tell me now here, R square plus omega 1 L whole square into what? Tell me now here, this is square root of, I think we'll move to the next page. If I take the ratio between these two, then what I will get, you tell me now here, PF1 by PF2. PF1 by PF2, which will be given as what we can say, tell me now, R by square root of, that is R square plus omega 1 L whole square into what? Tell me now here, square root of, that is R2 square plus omega 2 L whole square by R. So this value will come it as 1 by root 2 into PF2. Okay. So then simplify it. So this R will get cancelled. Now here will come it as what? Tell me now, R square plus omega 2L whole square by R square plus omega 1L whole square. I think it is a little complicated now here. If I use the first one, power factor is 1 by root 2 now, first one. So this is given as simply R by square root of R square plus omega 1 L whole square. Squaring on both sides will equate now here. This is R square plus omega 1 L whole square, which is equal to R square into 2. Okay. Now this is R square equal to that is R square equal to omega 1 L whole square. Okay, that means R in place of I can use this relation now here. So this is 1 by root 2 into, so P of 2 power factor P of 2, which will be equal to, this is R squared plus, so this is what I'll be now here 2000. So means 2002 square. So I can say this as 4R square. This is 4R square by, this is R square plus R square only. Yes, under root. Now you tell me now this is 1 by root 2 into P of 2, which is equal to, that is 5R square by 2R square under root. This is 1 by root 2 into 1 by P of 2, which will be equal to root 5 by root 2. Root 2 will get cancelled. So that means how much will come here? P of 2, which is equal to 1 by root 5. Good problem. Okay, next one. So a series LCR circuit with given L, C, and R connected across AC source. The power factor of the circuit is, yes, the power factor. Now let's find the impedance. Now Z is equal to R plus J into omega L. Omega, which is equal to, this is 100 pi. L value 100 by pi into 10 power minus 3. 10 power minus 3 minus 1 by omega c. So omega value, so this is 100 pi, c value 10 power minus 3 by pi. So that is z value will come to be what will be now 10 plus j into pi. Pi will get cancelled. So how many zeros now here? 3 zeros will get cancelled. 10 minus pi also will get cancelled. Now, so this is will come 10. Yes, so here the impedance is what I will get now, purely resistive now. So then how much the power factor, which is equal to 1. Unity power factor. Next one. In the given figure, an inductor and a resistor are connected in series with a battery of EMF E. Okay. Represent the maximum rate at which energy is stored in magnetic field. The numerical value of B by A is what they given now. The maximum rate at which energy is stored in a magnetic field. Where is A here? There is no A now. Might be some correction, maybe in the problem. Let me check it now here. Some correction. Okay, here, this is e power a. This is power a. Okay, an inductor and a resistor are connected in series with a battery of EMF, E volts. Okay. E power a by 2b represent the maximum rate at which energy is stored in magnetic field. And basically, energy stored by the inductor is half Li square, isn't it? Energy stored by the inductor is half Li square. Energy stored, which will be equal to E is equal to 1 by 2 L into I square. Now they ask him to find the rate of change of energy. We need to find what element dE by dt. So what the dE by dt we can say now here, you see is Li into di by dt. So that means we need to get the current we should get now. Yes, current through this inductor I, so which will be equal to inductor initially we have, so initial current. What is this IL of 0 minus IL of 0 minus, which will be equal to E by R. Next, IL of inductor, which is initially it is a inductor. In the transient state, will behave like an open circuit now here. So this is IL of 0, which will be 0. Next, IL of infinity, and which will be equal to E by R. Next, tau is equal to what element of here? L by R, which will be equal to 4 by 25. Now we can write it as now here IL of T, which is equal to, so here we have a, so here IL of final value plus initial minus final, initial minus final into e power minus t by tau, e power minus t by tau. So you can get it as IL of t. How much will come? Final value is how much now? E by R plus initial value how much now? 0 minus final value E by R into e power minus t by tau. T by tau is equal to here 25 by 4. So then this value will come to be what tell me now here? E by R into 1 minus e power minus 25 by 4 into t. This one. Now we need to get what tell me now? Di by dt we should get. Now here, so this means we got this IL of t, the current through inductor, which we got it as what tell me now? That is E by R into 1 minus e power minus 25 by 4 into t. Now we'll get it as dIL by dt. So how much will come here? This is E by R into 1 minus plus this is 25 by 4 into t into e power minus 25. Twenty-five by 4 into e power minus 25 by 4 into t. So we can say now dIL by dt, and which I will get it as Now here 25 by 4, that is E by R into e power minus 25 by 4 into t. Now what is the dE by dt now, which we have from this equation? Li into di by dIL by dt only now, which will come to be a L. I is how much? That is E by R into what element of 1 minus e power minus 25 by 4 into t. And this is E by R into 25 by 4 into e power minus 25 by 4 into t. Maximum value. Now dE by dt, and which will come it as what you tell me now finally, 25 by 4 into L into E square by R, E square by R square. That is 1 minus e power minus 25 by 4 into t into e power minus 25 by 4 into t. Now we need the maximum power. So this must be equated to 0. When I equate it to 0, so then we can get this maximum power. For maximum rate of energy, what we should do here, tell me now here. We can equate the dE by dt, we equated to 0. This is equated to 0. That means the only this term will become 0. 1 minus e power minus 25 by 4 into t, which is equal to 0. Now here 1 is equal to e power minus 25 by 4 into t. Now we'll get the time. So time is equal to what? Tell me now here. L by R into ln of 2. In this case, power is maximum. Finally, so this is dE by dt. We substitute these values. Will come it as what? Tell me now here. That is E squared by 4R. Finally, A is equal to power, that is 2, and B is equal to 4. They are asking A by B, na B by A. They are asking to find B by A. B by A, which will be equal to 4 by 2, which will be a 2. So this is 2. Next one. Next. In an AC circuit undergoes electrical resonance if it contains either capacitor An AC circuit undergoes electrical resonance if it contains either a capacitor or a inductor. No, it should contain both. An AC circuit containing a pure capacitor or a pure inductor consumes high power due to its non-zero power factor. Now here, now statement 1 and 2 both are false. It will does not consume the high power. So this 1 is wrong, 2 is also wrong. When the power is maximum at a resonance. Okay. Next one. When the frequency of AC source in a LCR circuit increases, the current in the circuit first increases, attains maximum, and then decreases. Yes. Series. Yes. Correct. The graph we have seen now. The current impedance Z value we have now, which is equal to what we know, R plus J omega L minus 1 by omega C. How the impedance now here? So then by combining here, it should be like this. The graph, impedance graph, how it is now when the frequency is 0. So this is now omega and the impedance. How the graph you tell me? So this graph, it will come to be like what you tell me now here. Yes, bowl shape like this will come now. At a resonance, it is a minimum impedance. Minimum impedance. Then what will be the current? You tell me now, current graph, it should be opposite will come. Yes, this graph, it will come to be like this. Okay. The current graph is opposite, like this will come. So first one is correct. The value of power factor at resonance is 1. Yes, correct. Both are correct. Next one. As per the given graph, choose the correct representation of curve A and curve B. Xc the reactance of a pure capacitive circuit connected to AC source. XL is the pure inductive circuit. Okay. Now what they are asking is equal to curve A, curve B given. B's are fine. B's no. B is remains resistance means constant, na? XC. Curve is a XC. Yes, correct. So this is XC only. And what about the B? This is XL. Yes, this is XL. Option C. 37. Next, a coil has an inductance. What is the Xc? Tell me now. Xc is equal to 1 by omega c na. It is a rectangular hyperbola. And what XL is equal to omega L. Linear graph na. So that's why. A coil has an inductance of 2 Henry and a resistance 2 ohms. 10 volts is applied across the coil. The energy stored in the magnetic field after the current has built up its equilibrium value is. Equilibrium value means steady state. That means they are asking to find the energy, so that is half Li square. Energy stored by the inductor, that is half Li square. Inst Coil has inductance and the resistance is there. In steady state, the inductor will behave like a short circuit. That is 10 by 2, which is equal to 5 amperes. So the inductance, which will be equal to 1 by 2, L is 2, and this is what will be now 5 square. So which is equal to what you tell me now here, 25 joules. Hmm? Current is 5 amperes. They are asking in terms of 10 power minus 2. Stored in the magnetic field and the current has built up a equilibrium value. Equilibrium value means steady state. In steady state, how much this value of current is constant. Inductor will behave like a short circuit. 10 by 2, 5 amperes. Next, maximum power is dissipated in a circuit containing an inductor, capacitor, resistor connected in a series AC source when a resonance occurs. Yes, a resonance maximum power only now. Maximum power is dissipated in the circuit containing pure resistor due to a phase difference between them is zero. Yes, correct. This is also correct. Both A and B are correct. Both statements are correct. A capacitor of capacitance 150 connected to an AC source. The maximum value of current in the circuit is approximately I is equal to what we can say now here, that is 36 into sine of 120 pi t by what I can say now here. So here 1 by j omega c. Then I value come to be what terminal j omega value how much now? 120 pi into c value how much now? That is 150 into 10 power minus 6 into 36 into what I can say now here sine of, that is 120 pi t. Now simplify it. How much will come? Maximum current, peak current only they are asking 120 into pi into 150 into 36 into 10 power minus 6 also there. So this I value which is getting it as a 2 into sine of 120 pi t. That means this is the maximum value now 2 amperes. Okay. Okay, fine. Yeah, that's it for today's class, and we'll continue. Next class will continue the remaining.